Hi, welcome to another 4AC word example. This time we look at August 2014 Past Year Exam Paper, Question 4. Question 4 reads as follows. Part A, refer to the circuit shown in figure 4.1. The switch was moved, this switch was moved to terminal A at the time t equals to 0. In other words, this battery starts to charge the capacitor. Calculate the time constant of the circuit and the steady state value of the voltage Vc. In other words, after quite a substantially long time, what is the voltage across these two capacitors? Assuming that the value of Vc is 0 at time t0, determine the mathematical expression of Vct and sketch the waveform. So that is part A, subsection 1. Subsection 2 says that the switch was moved to terminal B after time t is 40 milliseconds. We want to determine the value of Vct at time t equals to 40 milliseconds and the new time constant of the circuit. Right, so there's two parts to this. Now let's see how we can solve this problem. Well, let's look at the circuit when the terminal was switched over to A. The circuit is reduced to two resistors connected in series with two capacitors in parallel. Right? Therefore, the time constant tau is R total C total. For resistors in series, we just add them up, so it's 200 plus 200 ohms. And capacitors, we add the capacitance up as well, so it's 10 microfarad plus 10 microfarad. So that gives us 400 ohms multiplied by 20 microfarad. That gives us 8 milliseconds. Okay, so that's the time constant. Now, after steady state, initially when the switch is closed, this battery starts to charge these two capacitors. So initially the voltage over these two capacitors was 0, and slowly it increases until it reaches the same voltage level as this. And usually that happens more than 3 tau. 2 tau, 3 tau, it will already reach there. So after a steady state, the voltage Vt will be the same as the voltage of the battery, so it's 20 volt. Okay. And the charging characteristics can be written as Vt is equals to the initial voltage of the battery 1 minus exponential minus the time over the time constant. Okay, this is the charging circuit characteristic. So substituting the values in, we will get 20 1 minus e of t minus 8 milliseconds. That gives us 20 1 minus e minus 125 t. Okay, so that's the voltage waveform, the C. Now, the characteristic when we plot it on the graph will look something like this. T in seconds, maximum voltage V will be 20 volt, and the waveform will be when time t is 0. When time t is 0, this is 0, e to the power of 0 is 1, so 1 minus 1 is 0 here. Right, so it will go in such way, some kind of, until it reaches the maximum. At time 0, 0. At time 1 tau, it's about here. 2 tau, it's about here. And 3 tau, it's about here. So anything more than that, so this tau, 2 tau, 3 tau. Anything more than that, it would be the same as approximately 20 volts. So that's the waveform. Okay, so that's for part A. Part A, subsection 1 of this question. All right, now we look at section A, subsection 2. At time t is 40 milliseconds, which is about 5 tau, the switch is changed over to B. Right? Now, at 5 tau, the voltage across these two capacitors would have reached the maximum voltage, 20 volt. So, at that moment in time, when the switch was switched over, the voltage will be 20 volt. But this time, what happens now, as the capacitors discharge this way, the current flow that, the voltage begins to discharge through these two resistors. Therefore, now the new time constant tau is gain R total C total, which is now the new R, which is 20 plus 100, 300 ohms, multiplied by the two capacitance total. So it's 10 microfarad plus 10, so it's 20 microfarad. Right? So we get 6 milliseconds. So this is the new time constant for the discharging circuit. Now for discharging circuit, although this question never asked for it, the discharging circuits will look something like this. Right, where here originally is 20 volt, and here's time t. Alright, so that's the answer for part A, subsection 2.